Alright, so we have this new concept called a conjugate. Anytime you have a binomial, anytime you have something like, it could be x plus 6 or whatever, its conjugate is the exact same values, but with the sign in the middle switched. So x plus 6 and x minus 6 are conjugates. If you have something like sine x minus 58, the conjugate would be sine x plus 58. Easy. So here they just want us to practice some conjugates, and at the same time they're making us practice some more multiplication to make sure that we're solid at that. So 4 root 6 plus 3, we are given. The conjugate is 4 root 6 minus 3. And now we get to FOIL this. So 4 times 4 is 16. Root 6 times root 6. I could write root 36, but you know what's going to happen, right? It's going to come out to 6 in the end, so let's just cut to the chase. Outside, 4 root 6 times minus 3 makes minus 12 root 6. Inside, we get 3 times 4 is plus 12 root 6, and then 3 times negative 3 makes negative 9. So now when we clean this up, 16 times 6 is 96, take away 9, and we get 87. Minus 12 root 6 plus 12 root 6 cancels out. That's nice. Next one, minus 3 root 11 plus root 2. The conjugate is minus 3, oops, wrote that wrong, sorry. Minus 3 root 11 minus root 2. So notice here, don't go changing every sign in the expression. Sometimes rookies do that when they're first learning conjugates. The only sign that changes is the one right in the center between the two terms. Only that changed from a plus to a minus. Nothing else did. So now when you multiply these out, minus 3 times minus 3 makes 9. Root 11 times root 11 makes 11. Outside, we get minus 3 root 11 times root 2 makes minus 3 root 22. On the inside, we get 3 root 11. Oh, I see. I knew something was out of whack there. Minus 3 root 11 times negative root 2. So this first, the outside gives plus 3 root 22. On the inside, we get minus 3 root 22. And for the last, we get root 2 times negative root 2, which makes negative 2. Technically, it makes root 4, but you know where that's going to end up, right? So 9 times 11 is 99. Minus 2 is 97. And oh, again, these cancel out. What do you think? Coincidence? No, it's not. One of the major reasons that we use conjugates is because they cause this to happen. When you multiply a number, or sorry, a binomial by its conjugate, this ends up being a perfect square, meaning square roots in this will vanish. This last term will be a perfect square, meaning square roots in here will vanish. And these middle terms consistently cancel out. Nice. There's some ways that we can really take advantage of that, which we will show you in a bit. Let's see it work one more time. The conjugate of this is 5 root x plus root y. Sign changed, of course, that's why it's a conjugate. Now when we multiply this out, 5 times 5 is 25. Root x times root x is simply x. Outside, we get 5 root xy. Inside, we get minus 5 root xy. And for the last term, we get minus, I could say root y squared, but you know what's going to happen. We simply get y. And when we clean that up, we're left with 25x. A whole lot of nothing in the middle because these terms cancel out. And then we get minus y. The magic of conjugates.